Welcome to Yaskawa America's e-learning module for the V1000 Drives, Features and Benefits. Hello, my name is Paul Avery and I am an engineer in the Technical Training Department at Yaskawa America. I will be your instructor today as we go through this e-learning module. Every project needs an objective. The objective of the engineers at Yaskawa was to double the life of their already robust microdrive, the V7. Given that the V1000 is properly sized and installed, and assuming a reasonable 40°C ambient and a consistent load not exceeding 80% of drive-rated current, the V1000 will probably last as much as 10 years or more. To achieve such performance, even the normal wear items of a drive, such as cooling fans and bus cabs, must also be designed to a tougher standard. Also, circuit boards are interconnected using solderless joint design, which tests prove increase the drive's vibration tolerance from 20 Hz to 50 Hz. To improve quality even further, a complete revision of Yaskawa drive production lines has taken place, and human error has been reduced by installing the most advanced robotic technology available. Another way to extend the life of drive components is to reduce the heat that they are subjected to. To these ends, Yaskawa Drives engineers utilized a special thermal simulation program to help them optimize the locations of certain components and improve airflow within the drive. The diagrams shown here detail how the maximum expected heatsink temperature was reduced by almost 7 degrees Celsius by just optimizing component location. After optimizing the component locations, the next step in reducing the heat affecting drive components is to make the heatsink cooling more efficient. Yaskawa Drives utilize a heatsink design that promotes air turbulence while the air flows over the heatsink. The effect of the turbulence is that the cooling air spends more time in contact with the fins and thus is able to do more cooling. Design also incorporates features that promote the chimney effect, which has been proven to improve convectional cooling for electronics. Yaskawa engineers strove to simplify the construction of the V1000. The number of mechanical parts in the V1000 was reduced by up to 35% over the V7 drive, and by over 50% when compared to the comparable, larger 7th generation Yaskawa drive. The reduction in mechanical parts will improve the expected drive lifetime by reducing the chances of mechanical wear and tear. The V1000 also gave the engineers the chance to reduce costs to build the V1000 by reducing the number of screws used in assembling the drive. The quantity of necessary assembly screws was reduced by up to 54% over the last generation. This exploded view of a construction of a 1-horse V1000 details the simplified design of the drive. The simplified design reduces assembly time, thus reducing costs and improving production rates on the new robotic lines that build and assemble the V1000. On this size of the V1000, the actual power board is split into two to improve functionality. Power is divided from control and protection. Though the larger size V1000 shown here features a few more pieces than the smaller one featured on the previous slide, the overall design is simplified and optimized when compared to the previous microdrives. Like you might find in a much larger drive, the V1000 features a dual duty rating setting. When set to heavy duty, the drive will allow for 150% of rated current for up to 1 minute and offer a high carrier frequency setting for quiet operation. If, alternatively, the drive is set for normal duty, the overload is reduced to 120% for 1 minute, but at a higher continuous 100% rating. The carrier frequency will default to 2 kHz and a current D rate will be applied if the carrier is raised above 2 kHz. The effect is that using the normal duty setting will allow the drive to adequately power a larger motor than the V7 drive with its single duty setting would be able to. The limitation is the reduced overload capability, so knowing the application is a requirement. Let's use an example to illustrate what we just covered. The motor we want to drive is a 230 volt 3 horsepower motor that will be rotating a fan. The motor's full load current rating is 9.6 amps. If we are going to drive this motor with a V7, it would require using a 3 horsepower model that has a continuous current rating of 11 amps. If, however, we use a V1000, we have the choice of normal or heavy duty. Because this is a fan application, we don't require much overload, so 120% will be plenty. Therefore, a normal duty configured 2 horsepower V1000 will meet the requirements of the motor. It should be noted that the normal duty setting isn't just for fans and pumps, but even for constant torque applications, as long as the overload required doesn't go above 120% of the normal duty current rating. Another exciting feature of the V1000 is the new possibility of side-by-side mounting of the drives. Side-by-side mounting means more drives can fit into a smaller space, thus saving money on cabinets and enclosures. Even when the ambient temperature is not optimal or the output transistors are working harder and faster, producing more heat, Tight installations are still possible with a current D-rate. Parameter L835 will tell the V1000 whether the installation is indeed a side-by-side installation and if a D-rate in protection times is necessary. For all side-by-side installations, the top cover of any V1000 will need to be removed to promote airflow over the internal components. If the ambient temperature can be kept at 40 degrees C or below, and the carrier frequency is acceptable at 2 kHz, then side-by-side operation is possible without any D-rate at all for a drive configured for heavy duty. Part of drive operation requires the drive to compensate for the loss of voltage due to the resistance of the motor's stator windings, also known as R1. When a Yaskawa drive is auto-tuned, the drive will calculate how much extra voltage needs to be sourced to the motor in order to compensate for the drop. Auto-tuning is a good first step, but as the motor gets hotter, the resistance of the stator increases, and so does the voltage drop, which leads to a loss of motor torque and possible speed inaccuracies. As an example, if the resistance of a stator increases by 20%, then the effective voltage used to create a magnetic field is limited and the possible motor torque is reduced. This restricted motor torque will lead to an inability to maintain speed. Since stator resistances can change by as much as 40%, or twice our example, then a single step to compensate is not enough. The V1000 now offers a parameter to enable online tuning of the ever-changing R1 value. The drive will compare calculated references and measured feedback values in order to create an R1 compensation value. The graph shows how a properly compensated value due to having the online R1 tuning enabled will require less slip to produce torque than the same drive with online tuning disabled. All this means that there is better low-speed accuracy with the V1000 no matter how hot the motor is. It wouldn't be a microdrive if we didn't take some time to mention the physical size. Now the V1000 isn't as small as your MP3 player or your cell phone, but the V1000 is a miser when it comes to acreage. The under 5 horsepower size remains unchanged in volume from its V7 cousin, but the 7.5 and 10 horsepower versions take up nearly 50% less volume than the V7. Up until now, we have needed separate drives to run our induction motors, our surface-mounted permanent magnet motors, and our internally mounted permanent magnet motors. This hassle meant more purchasing, stocking, and there were learning curves for the different drives. Chances of having to interact with multiple vendors to meet all of our needs was likely. Now, the V1000 has the ability to drive them all. To enable permanent magnet motor control, the standard control method selection parameter just needs adjustment. After setting the proper control method, the drive will need information on the particular permanent magnet motor being used, programmed into the drive's E5 parameters. Commutation is done by the drive, so no feedback is required. A V1000 configured for permanent magnet motor operation can effectively operate over a 4:1 speed range, making it ideally suited for fan and pump applications that only require high torque at high speeds. The real benefit of all of this is the space and energy savings gained by using permanent magnet motors. The upper box on this slide compares the volume of a typical 5-horse induction motor versus the same horsepower from a permanent magnet motor. An impressive 70% savings in total space occupied is the benefit of using the permanent magnet motor. Energy is saved by using a permanent magnet motor as well. Comparing a typical permanent magnet motor versus a typical induction motor, or even a high-efficiency induction motor, will reveal that the permanent magnet motor is more efficient than the other two motor types up through 5 horsepower. When using a V1000 to control a permanent magnet motor, it is possible to take advantage of a special braking possibility. With a permanent magnet motor, if all of the positive bus transistors or all of the negative bus transistors are closed together, the motor's windings are shorted. The induced voltage will create a braking current that can be used to stop a freewheeling motor or resist any motion from a stopped motor shaft. The V1000 allows this short-circuit braking via either a digital input or pre-programmed at the end or beginning of a run command. Care will have to be taken when applying the short-circuit braking because too large of a braking current can lead to motor demagnetization. The threat of demagnetization is most likely if the drive is oversized for the motor. The superior thermal design of the V1000 affords the drive to be installed in high-temperature applications with little or no current derating. If the V1000 enclosure is the open chassis specification, then the drive requires no current derate up to 50 degrees Celsius and only requires a 15% derate if the enclosure is a more airflow restrictive NEMA Type 1 enclosure. Having a higher ambient temperature capability may translate to a smaller enclosure and maybe a smaller cooling device. A downside to some drive installations is the amount of audible noise generated by the motor at low carrier frequencies. Usually the lower the carrier frequency, the more audible and irritating the sound. The V1000 offers new carrier frequency selections that help reduce the amount of acoustic noise while using lower carrier frequencies. The video on this slide shows a simulation of the reduced peak noise levels exhibited by the V1000 versus a V7 drive. What is being accomplished is that by sweeping the carrier frequency over a range of frequencies, Yaskawa has spread the noise over a range and not allowed it to peak at any particular frequency, thus reducing the maximum decibels. All of the new swing PWM settings are centered around the 2 kHz frequency and are mainly targeted at drives set for normal duty settings, since low audible noise for a V1000 set for heavy duty can be fixed by using a higher carrier frequency such as 8 kHz. Still, even for heavy duty, a lower carrier frequency like one of the swing PWM selections may be desirable, since a lower carrier frequency means decreased output transistor heating. Please advance to the next slide to sample audio files of a few of the carrier frequency selections. The video of the last slide has been replaced by clickable speaker buttons for the standard 2 kHz carrier, the now default swing PWM number 1, and also a sample of swing PWM number 4. Please click on each speaker to hear a sample of each setting and then advance to the next slide. The V1000 offers many improvements over what has come before it. Some of the improvements are monumental, and some are smaller changes that may actually be just as important to some users. Some of the smaller improvements that may not warrant a full slide to themselves, but are important enough to bear mentioning, are listed here. Some of the items listed are functions that one would expect from a more full-featured drive, not a micro drive. Also of note, but may be hard to understand, is the common control board. In the past, the V7 needed different control boards, one for the larger sizes and one for the smaller sizes. This led to multiple separate versions of any software written for the drive, which slowed development of custom programming. Separate versions of software is not an issue for the V1000 because it uses a single control board for all sizes and voltages. A new generation drive deserves new generation software tools. DriveWizard Plus is a new version of an old friend. It will not replace the current version of DriveWizard that is for use on all 7th generation Yaskawa drives, but will be used exclusively by the V1000 and in all of the new generation of drives set to be released over the next few years. There is no backward compatibility for DriveWizard Plus in the 7th generation drives. DriveWizard Plus will offer a new interface that will offer extensive layout customization. The tools available within the new layout are new as well. There will be better trending or graphing of drive monitors with faster update times for serial connections. The software will also allow the user to map out a run routine for the drive to run a single time or loop through over and over again. The software offers a tabbed layout style that will allow the person interfacing with the software to jump easily between different monitoring styles like graphical monitoring or spreadsheet monitoring. Another quite nice software tool for the V1000 is the DriveWorks EZ PC tool. Background on DriveWorks EZ is that it is a customization tool that allows unique programming to be written to the drive using a PC tool. The V1000 will offer 2 levels of DriveWorks EZ. The first level is DriveWorks EZ Standard. It will not cost any extra licensing fee, but the PC tool will only be available by attending factory training for the V1000. Each copy of the PC tool given out at training will be registered, each customer assigned a customer ID number, and a database of users will be maintained. The registration database will help Yaskawa with any product revisions that get released to get to the people that need them. An important note about the standard version of DriveWorks EZ is that there will be no technical support at 1-800-YASKAWA for using DriveWorks EZ Standard. That is why copies of the PC tool will only be available for those that attend factory training. A second level of DriveWorks EZ available will be the Pro version. Training for the Pro version will be a standalone class dedicated to only DriveWorks EZ and will be required for all Pro users, even those that attend the standard V1000 programming class. Again, there will be no licensing fee for the software, but a $1,500 class fee will be the de facto cost of the software. The difference between the standard and Pro versions are not just in how they are acquired, but also in their capabilities. The standard version will be somewhat of a limited version of what is available in the more fully featured Pro version. Students of the Pro class will be allowed to call the tech support group with their DriveWorks EZ Pro questions, and the students of the G7 Drive version of the DriveWorks EZ will not be obligated to attend the V1000 Pro class to acquire the Pro version. A V1000 Drive software simulator is available at our website, Yaskawa.com. The simulator is a program that will mimic operation of an actual V1000 drive. All of the keypad buttons that exist on the V1000 will be clickable on the simulator, which means that the virtual V1000 will be programmable just like a real drive. Both analog and digital inputs can be manipulated as well, and the analog and digital outputs are displayed so that their operation can be tracked. The simulator will even be able to simulate a loaded motor. The benefits of this free software is in the ability for users to test and troubleshoot V1000 operation without actually having a drive in front of them. It will also be an excellent tool for teaching others how to use the V1000 drive. The software will be available at www.yaskawa.com, but will only be available with a partner login. A copy of the software will also ship with the drive on a product CD. Probably the most important specification of the V1000 is the available power ranges and the normal duty and heavy duty current capabilities. I won't bother to read off what can easily be read from the screen, but I will point out that Yaskawa does offer single-phase V1000s up to 5 horsepower, and that the V1000 can go up to 25 horsepower with 3-phase power. These are both firsts for Yaskawa microdrives. While we are talking about heavy duty and normal duty, it is good to remember that the normal duty allows 120% overload for 1 minute. The heavy-duty setting has a reduced current rating, but allows a full 150% of rated current for 1 minute. Another first in a Yaskawa microdrive is that the open-loop vector control of the V1000 is based on current vector control. The V7 method of vector control utilizes voltages to adjust vector performance, whereas the V1000 uses more sophisticated current measurements for vector control. The actual control is more accurate and faster using direct current vector regulation. The end result is that up to 200% of rated motor torque can be produced at speeds as low as 1/2 of a hertz. In the last generation of Yaskawa drives, the user was allowed to pick out certain parameters and give the drive operators access to only those parameters. These parameters were referred to as user parameters and were selected by parameters A201 through A232. In the V1000, the user parameters are still there, but now the user can vary their application. A new parameter, A233, now allows the user to set the drive to pre-populate the A2 parameters with programming that corresponds to the user's selected application profile, and then the leftover A2 parameters will store any recently changed parameters as the user changes them. The end benefit is that a new menu called the Setup menu will contain only these most necessary parameters for the current application and make them more readily accessible. More information about application profiles is on the following slides. A first for any Yaskawa drive is the V1000's application preset feature. With a single parameter setting, the drive can easily and quickly be configured for some very common applications, including pumps, fans, and compressors. As mentioned on the last slide, one of the benefits of the application preset is that it preloads the A2 parameters with the appropriate parameters of concern that are then accessible in the new Setup menu. Because most of the work of setup is handled by adjusting one parameter, the startup of the V1000 is very simple. By selecting one of the preset applications, parameters for the selected application are automatically adjusted to optimal values. On top of that, any digital or analog inputs and outputs commonly used for the selected application are configured for the appropriate functionality. Here's an example of how the application preset parameter works. Step 1 is to make sure that the drive is a blank slate. The application preset will not work over top of other programming of the drive. That can be done after the application preset is selected. Next, simply navigate to parameter A106 and select the setting that fits your application. For our example, we will select a conveyor. When we do this, certain parameters get adjusted to the most appropriate setting for a conveyor application, while some parameters automatically get loaded into the A2 user parameters. Remember that when parameters are loaded into the A2 section, they can be easily accessed and adjusted from then on using the Setup menu. Now we are ready to run the motor, or we can go on and adjust further parameters that may be beneficial to our application, but are not necessarily part of our conveyor application preset. Another innovation for the V1000 is the use of dual processors in the drive operation. By splitting the workload between the two brains, the functions of each can be optimized and thus allow much faster operation of critical drive processes. The Luna processor scans at a speed that is dependent on the carrier frequency but is in the microsecond range. The Gaia processor runs the main drive operation, including the functions that we as users program into the drive. The 2 millisecond scan time used by this processor is the fastest offered by any Yaskawa drive, not just microdrives. The benefits of all of this is best illustrated by the video clip. It shows how the V1000 stacks up against the V7 when it comes to detecting and acting upon a digital input. A V1000 offers a new variation on motor thermal protection that will help users meet upcoming specifications. Per the National Electric Code, drives will need to go a step further to protect the insulation of motors adequately. The new specification requires that overtemperature protection must offer a memory selection that will retain the elapsed I2T thermal protection time even if the drive is powered down. It is expected that UL will write this same requirement into their next 508C update. Yaskawa will meet the requirements by offering the user the choice of whether to hold the I2T value at power down or not, with the factory default state being that the I2T value is held. The V1000 is not a closed-loop drive per se, but there is within the drive the opportunity to tighten up the speed regulation by feeding the drive a single channel from encoder feedback. The ability for the drive to compensate for varying slip allows for better speed regulation when using the V/F control mode. An important facet of this simple closed-loop operation is that the V1000 will allow the user to adjust the performance via a PI loop known as the Automatic Speed Regulator, or ASR. An ASR is something normally found in the closed-loop capable drives like the F7, G7, or the future A1000 drive. It is not new for a Yaskawa drive to offer built-in multi-drop serial communication, not even from a microdrive. What is new is the fact that the V1000 ups the ante by allowing speeds up to 115,000 bits per second. Add to that the V1000 will also offer as an option the Y-Stick, which is a USB-based device that will allow easy transfers of drive parameters between similar V1000s or between a V1000 and a computer with DriveWizard Plus. For those of us that are familiar with Yaskawa's part numbering system, there is at least one major divergence with the V1000. Previous Yaskawa part numbers included the drive's power rating as part of the part number. Starting with the V1000, Yaskawa will start using the drive's output current rating as part of the part number in place of the power rating. For the V1000, the output current number will correspond to the normal duty output current rating of the drive. Maintaining safe drive applications is of concern to us here at Yaskawa Electric. So is saving our customers money. To help meet both of these requirements, the V1000 is one of the few microdrives in the world to offer built-in safety features in the form of hardware base blocks that will prevent any output from the drive using redundant hardware to block IGBT gate signals. The version of the V1000 sold here in North and South America will offer one hardware base block and 7 digital inputs, while the version sold in Europe will offer 2 hardware base blocks and 6 digital inputs. The divergence has to do with meeting IEC requirements in Europe. A big plus of the built-in hardware base block is that it meets the requirements of EN 954-1, Safety Category 3, Stop Category 0, which in some cases will satisfy the application's safety requirements and save the user the cost of a motor contactor. The V1000 will offer a new braking function that is an improvement over the high-slip braking used by our last generation drives. The new high-flux braking function will be enabled via a parameter, but will not require a digital input to initiate it. The function manipulates the motor's magnetic field to increase energy loss in the motor and prevent an overvoltage fault while the motor decelerates. The 2 oscilloscope captures show the contrast between braking with and without high-flux braking. The decel time without an overvoltage fault is nearly cut in half with no extra equipment to purchase like is required with dynamic braking. The amount of braking time that can be cut by high-flux braking will be dependent on the motor's characteristics and the application's duty cycles. The most important improvement offered by high-flux braking over previous solutions is that reacceleration without a complete deceleration to stop is now possible. To complete our description of the new high-flux braking feature, there are a few pieces of information that will be good to know. First, even though we have the new braking function, high-slip braking is still available in the V1000 via a digital input function. It will function the same as it did in the 7th generation Yaskawa drives. Second, the stall prevention function is mutually exclusive with high-flux braking, so there is a chance that without proper adjustment, an overvoltage fault can still happen if the decel rate is set too short. Lastly, because motor losses and thus motor heating is part of how high-flux braking works, it should be noted that the extra heating will not be figured when we are calculating the OL1 thermal protection time. It will be important that the user be aware that there is a duty cycle limitation to high flux braking that is akin to the limitation of full load across the line starts. A new feature that may just save a lot of a user's valuable time comes built into the V1000's removable terminal board. The control terminals of the V1000 reside on a removable board just like they do on most 7th generation Yaskawa drives, but now the board features its own non-volatile RAM memory. As the user changes parameters in the V1000, the changes are automatically mapped to the removable terminal board. There is no copy operation that needs to be performed in order to stay up to date, as there was with the copy keypad feature. The beneficial upshoot of this feature is that replacing a damaged V1000 and getting back up and running is a snap. A few notes about usage of the non-volatile memory of the terminal board. When a terminal board is plugged into a drive, there is a process wherein the parameter settings in the drive are compared to what is stored in the terminal board. If the parameters are for a different specification, meaning a different software version, then there is no possibility of downloading the settings from the terminal board to the drive. You will only be able to power down, remove the terminal board, and try it on the correct specification drive, or leave it in the drive and initialize the drive, which will wipe out the settings saved in the terminal board. If upon inserting the terminal board the drive displays an OPE01 fault, the drive and terminal board have different kVA settings. Simply adjusting the setting of 0204 to the size of the drive being used will clear the fault, and then allow the next fault, an OPE04, to happen. The OPE04 is a fault that tells us that the drive and the terminal board have different settings. The OPE04 fault is cleared by using a 5550 initialization of the drive, which will write the parameter values from the terminal board to the drive. Certain features of the V1000 spring from special application solutions Yaskawa has created in the past for other drives, such as the origin of the enhanced PID capabilities of the V1000. The V1000 offers PID functionality for 3 inputs, limits for PID input and output, and high and low feedback alarms, and more. For the last few years, Yaskawa has been pursuing ROHS Compliance for its products, and the V1000 is the first standard product that offers it across the board. ROHS Compliance is an environmental standard that restricts or eliminates certain dangerous metals from being used in products, knowing that later when the product reaches the end of its life cycle, disposal of the product may have an unwanted environmental impact. ROHS Compliance is mandatory throughout Europe and is on the very near horizon in Canada and California. Yaskawa anticipates that it will be the world standard in the years to come. The V1000 will ship standard with a non-removable 5-digit LED keypad. Unlike the V7's keypad, the V1000 keypad will have a shift key, making navigation much more like the other standard Yaskawa drives that use LCD keypads. The shift key will also function as a reset for drive faults. As shown on a preceding slide, the keypad offers an RJ45 jack that will access the drive's built-in RS45 communications, which are rated at 115,000 bits per second, and will allow communications with a computer via the USB option called the Y-Stick, part number JVOP181. The design of the V1000 gave Yaskawa engineers the chance to correct an issue that had befell the V7 drive. Though the heatsink fans of all V7s worked just fine, when time came to replace older fans at the end of their lifespan, users found that the bottom-mounted fans were hard to get to due to the fact that all of the drive's power wiring was hanging directly in the path of the user's hands as they tried to access the fan. Now with the V1000, all of the heatsink fans are mounted on top of the heatsink for ease of accessibility, yet able to withstand the heat coming off the heatsink. On top of this, it requires no tools or removal of the drive to replace a heatsink fan on any size V1000. It bears repeating the V1000's design is superior to our already industry-leading microdrive line because of the 50% reduction in mechanical parts used in most sizes. The reduction in number of parts helps us increase our mean time between failure rating and helps us to reduce the chance of parts shortages due to vendor issues. That means Yaskawa will always have the size you need in stock, or be only a few days from filling even large quantity orders. Monitors in a Yaskawa drive are the drive's way of telling the user the status of the drive operation via the keypad display. The V1000 monitors will seem familiar to users of Yaskawa's 7th generation drives, but with some new twists and new monitors. Most of the very basic monitors are grouped within the U1 group of monitors, with a few new monitors shown here in orange, including a monitor that will tell the user which parameter setting is giving them an OPE fault. The U2 and U3 monitors will remain the fault trace and fault history respectively. The new twist on the fault trace in the fault history is that the drive parameter initialization will no longer reset them. They will only be clearable via a new parameter, 0411. The new U4 group of drive monitors are targeted at helping the maintenance person better anticipate drive issues. The user will be able to find out the expected remaining lifetime of 4 of the drive's major wear items, including bus capacitors, cooling fans, and output transistors. The expected lifetime will reflect factors such as load, temperature, and carrier frequency, among others. The U4 monitors will also include information for operators wishing to find out how hard the drive and motor are working by displaying peak currents and elapsed I2T time of the motor overload protection. The V1000 now offers even greater options for sources of the drive's frequency reference and run command than any Yaskawa drive has offered before. But with new choices comes the chance to lose track of which source is active. So to that end, there are now monitors that will clarify which source is currently being used. There are also monitors to show values being received by the drive from serial and option board sources. These monitors will help with proper scaling of information being received via communications before the run command is given. Finishing out the monitor slides are the last 2 groups of monitors, the U5 and U6 monitors. The U5 group will display drive information regarding the external PID loop if one is active. The U6 monitors have to do with vector operation and the automatic speed regulator if the simple closed loop function is being used. The V1000 will help with uncovering potential trouble spots in drive operations by offering a new high current alarm. If during operation the drive outputs more than 150% of the drive's rated output current, the keypad will display characters HCA for high current alarm. It is also possible to turn on a digital output in case of any drive alarm, which would include the high current alarm. Because this is only an alarm, drive operation will not be interrupted during the alarm, but high currents can lead to faults, which will shut down operation. Hence why it can be useful to be aware of high current situations that might be remedied by adjusting a parameter. To widen the application base that can utilize the advantages of the V1000, Yaskawa offers the drive in a NEMA Type 4X enclosure that is also IP66 rated. Features of the 4X IP66 design that make it easy to use are larger keypad buttons that offer a responsive feel, letting gloved hands know that the buttons have been pressed, a toughened polyester overlay to resist tearing, and windows in the cover that will allow networking status LEDs to be viewable through the cover. Mounting hardware is stainless steel and captive, while the rest of the enclosure is made of a mild steel with an epoxy coating applied using a UL specified process. Of course, the design is UL, CUL, and CE approved for washdown duty. There will be some differences between the V1000 4X design and the standard V1000 drive. The V1000 4X solution will come with a different software version than the standard V1000. The differences are minor but involve fan operation and the fact that the 4X solution uses a new keypad design. All standard V1000s come with external fans. The V1000 4X only requires heatsink fans above 30 amps at 240 volts and above 17.5 amps at 480 volts. Another departure is the fact that the V1000 4X has 6 enclosure conduit holes. The drive ships with 4 filled with rubber bushings and 2 empty. The 2 empty ports are for power in and power out and will be filled with customer supplied cable glands. There are also significant differences between the V1000 4X and the previous Yaskawa 4X solution, the V7 4X. The V1000 4X extends to higher horsepowers than were available in a NEMA 4X V7, and the V1000 4X also includes drives rated for single-phase operation, further expanding Yaskawa's NEMA 4X offerings. Unlike the V7 4X, the V1000 4X will not require an optional ring kit when adding any of the many V1000 network communication option boards. Another expected option is the full-text LCD keypad that will be available for remote mounting with any V1000 installation. The keypad will be larger than the standard LED keypad that comes with the drive, so remote mounting will be the only option for its use. The planned LCD keypad will offer 2 new buttons called soft keys that will have functions assigned to them by the user via drive programming. Communication options have always been very important to Yaskawa, and the V1000 will be no exception. What is new is the option port that the optional communication boards will connect to. The V1000 has a 1 megabit per second serial port in place of the older dual port RAM option port that was used on previous drives. Using this port will be the Profibus DP option card and the upcoming DeviceNet, Ethernet IP, and Modbus TCP IP option cards, amongst others. The V1000 will offer the possibility to separately power the processors with a 24-volt DC power supply that will connect to the drive via a ribbon cable passed into the right side of the drive. The upshot of this backup power possibility is that even if the incoming line power is lost, the drive will be able to continue communications with the outside world, which may be important for maintaining a stable communications network. Another use that may be possible is to use the 24 volts to power the drive for programming purposes without needing high voltage line power, which itself might require extreme measures for arc flash safety purposes. Standard on the European version of the V1000, but as an option for North and South America, is the screwless version of the removable terminal board. The advantage of the screwless version is that vibrations cannot cause unthreading of a control connection and can be a savings of time during installation. Use of the screwless terminal board will require a solid conductor or a stranded wire with a ferrule. Other options to be released in the near future are listed on this slide. Of note, the C1 CE filter is the same option that is available for the V7, except that there will not be foot mount filters available for the V1000, only side mounts. This concludes our presentation of the proud new addition to the Yaskawa family of drive solutions. I hope that you take away from this that Yaskawa is pushing the envelope again with powerful features in the smallest size drive currently on the market. The V1000 provides a world of power in the palm of your hand. Thank you for viewing this Yaskawa Electric e-learning module. We hope that the information we presented was indeed informative and helpful. If you would like additional training, please contact us through any of the methods shown on this slide. Thanks again and have a great day.